The broadcast is now starting. All attendees are in listen-only mode.
Good evening, First Robotics community. My name is Sean Lim, and I'm the Director of District Implementation at First Robotics Canada. And thanks for joining us for another installment of Ask the Experts. And this is actually our last webinar before Stop Build Day. And so this is a really important one because as your teams are scrambling to finish their robots, there are certain high priority things that you want to make sure that you do in order to pass inspection. And so those are things you're going to want to take care of before you lock your robots and put them into the bags, which is called the bag and tag procedure. We're going to talk about that a little bit today just to make sure that you do it properly, because even you sealing up and locking up your bags, that's something that the inspectors are going to be checking at the event as well, just to make sure that you've done it properly. And we're also going to talk about two other interesting things where most teams are not finished building their robots. There are still some opportunities to be able to work on parts of your robot, even while your robot is locked up in its bag, and they're called the Withholding Allowance and the unbag periods, and we'll go through some of the details with those. But joining us this evening, we've got Paul Keenan, of course, our first senior mentor from First Robotics Canada as well. Paul, how are you doing this evening?
I'm fine, thank you, Sean. Glad to be here.
Glad to have you as per usual. And Paul will be moderating this evening, so if you have any questions or comments all throughout the webinar, please make sure you open up that chat window and ask them, and Paul will try and squeeze them in during the webinar, if not during our question and answer at the end of the webinar. But for our expert panelists this evening, we have a very special guest with us, a very definitive source on a lot of these robot inspection questions, because we have Karsin Lam with us, who is actually our district senior lead robot inspector for the Ontario district. And so Karsin does coordinate the lead robot inspectors in the province. And Karsin, it's great to have you on board with us. How are you doing this evening?
I'm doing pretty well, thank you.
Great. Well, thanks for joining us, Karsin. And without further ado, this shapes up to be a really important webinar, and let's just get started. Let's talk a little bit just about robot inspection and what it is for our newer teams. But when you arrive at the competition, one of the first things you're going to want to do is get your robot inspected by one of the robot inspectors there. And the reason is that you are not going to be able to compete with your robot unless it has passed its inspection. And so you'll find that the more experienced and higher performing teams, literally the moment they are allowed to get it inspected, they will start that inspection as soon as possible. And so I'm going to highly recommend that basically as soon as you can, start that inspection process and aim to pass it as soon as possible. And there's a couple of reasons for this. If you start the inspection process and there are issues with your robot, you want to know about them earlier rather than later. And so there are a lot of teams who actually do put it off until, just before the matches start. And then there's a bunch of issues which crop up, and there's no way that they can fix it in time, and they end up missing matches. And so there's really no harm in starting the robot inspection earlier, just so that there are any problems identified earlier on. There's a really good reason to finish it, to pass inspection early as well. If you're a team that needs a fair amount of practice with your robot on the real field. And you know what? That should apply to every team, no matter how good you are. Time to be able to practice on the real field is exceedingly valuable. How it works at competition is that when there are practice matches, there's something called a filler line. And what happens is if a team cannot make its regularly scheduled practice match, they don't just let that spot go empty when they're running that practice match. What they'll do is they'll then draw from teams which are in line in what's called the filler line. And the first team in the filler line, they'll say, hey, you want to jump onto this match and practice? And you can go ahead and do that. But you can only join the filler line if you have passed inspection. And so another nice little carrot on a stick for you guys to start inspection and to pass it as quickly as possible. And so let's talk about what inspection actually involves. And so, Karsin, I'm going to put you onto the spot as we do this, but what has actually been released by First Headquarters just a little while ago was the official 2017 Steamworks inspection checklist. And so this is the exact same checklist that a robot inspector at an event will be using to pass or fail your robot. And so, Karsin, I might hand this one over to you if you don't mind, but if we could take a moment and actually just go through these items on the inspection. Most of them are pretty self-explanatory, but Karsin, I'll go ahead and scroll through the items as you go, but why don't you give us your insights on what an inspection looks like?
Sure. So typically, when you decide that you needed to go through inspection, you would come over to the inspection station and we can start you on the process. And the very first thing you do is that robot weight. We have a scale set up and we weigh your robot without the bumpers and without the battery. So that 120 pounds does not include those two items. So once we weigh you guys and make sure that you guys are under 120 pounds, we will also weigh your bumpers because they do have their own separate 20-pound weight limit per set. And we will record all of that stuff in the fields you guys see on the right side of the sheet.
And I'm going to jump in on that one super quickly, yep. Karsin, because those scales, they have a precision of 0.1 pounds. And so if you are at 120.1, you are over the weight limit. And so you'll be sent back to reduce the weight on your robot. But if you're at 120.0, right on, then you do pass.
Yeah, exactly. And right off, so yeah, as soon as we see your weight, we can start the rest of the inspection after that. So after the weigh, we will go into the starting configuration, which is basically to make sure that your robot can start within the frame perimeter. And I guess we would want to kind of explain what the frame perimeter is. If you were to look at the rules, the frame perimeter is kind of described as if you were to wrap a string around the frame of your robot, if you wrapped a string around your robot, you would be able to visualize a continuous frame around your robot, and this is considered your frame perimeter. And a lot of rules kind of revolve around this, especially the bumper rules and this starting configuration rule. So if we go back to the checklist, basically this check is just to make sure everything can start inside that frame, and the check is very basic. We generally just roll your robot up against the wall and make sure only your frame touches the wall. And little things like bolt heads and nuts, little protrusions like that, that is fine. But we don't want to see like air tanks hanging off the side or gears overhanging the frame perimeter. Those things, when we do see those things, we will ask you guys to figure a way to bring those parts in. And then moving on to the next item, max robot size. This is a new volume size that we have this year. They gave options for two configurations. I guess the best way to describe them is really the tall bot or the wide bot. A being the wide bot and B being the tall bot. And same thing, just as simple as it is, we would measure your robot with the measuring tape and just make sure you guys fall within those sizes. And a good point to point out is that this size does include your bumper. So when you inspect your own robot before you bag it, which is highly recommended, make sure your bumpers are included in that size. If it's not, it might be something to add onto your checklist to fix.
Yeah, and we're going to talk about this one quite a bit later on, because when it comes to rules that we think are going to be the most commonly broken rules, this is probably going to be one of them, because that's a change from prior years. In prior years, when we had maximum volume rules like this, generally they did not include bumpers, but this year they absolutely do include your bumpers 100%. So you need to make sure that your robot with bumpers on will fit into one of these two chosen robot dimensions. So thanks for bringing that one up, Karsin. We'll talk about that one a little bit more, just to hammer that point home, though, later on.
Yep. And then the frame perimeter must not articulate. That's pretty straightforward. We want to make sure that the frame perimeter itself isn't it's a solid frame. It's not something that will shift around in your robot too much. something that your bumpers will be attached against, and it should be a very solid part of your robot.
Okay. And Karsin, can you just talk about the plane configuration really quickly?
Oh.
Because you are allowed to have a little part of your robot sort of extend a little bit outwards, but there are limits to how far it can extend, right? Because your robot attachments can extend beyond your frame perimeter, but they can't extend. Can you describe that for us, I guess, in the most succinct way that you know how? It's a little tricky to explain.
So there are basically, for a robot, there are two configurations. There's that starting configuration that we talked about, where every part of your robot, other than your bumpers, has to be within that frame at this beginning of the match. And then once the match begins, your robot can start extending past your frame perimeter. It can extend even past your bumpers if you designed it that way. The only limitation to that extension is that max robot size.
All right.
The 36 by 40 by 24 or the 30 by 32 by 36. So that giant volume, the A and B volumes, those are the plane configuration volumes. So if you were to design a robot that had bumpers much smaller than those configurations, you are able to design parts of your robot that extend past even your bumpers. I guess that's the simplest way I can explain it.
Oh, I think that was really,
configuration.
I think that was really good, Karsin. So yes, you are allowed to extend beyond your frame perimeter, but you still can't extend beyond these maximum volumes. So very nice. All right, Karsin, keep on going. Bumpers.
Yeah, bumpers. So bumpers, I think we're going to be talking a bit more about them later on as well. They have their giant list of rules that they have. Most of them just really talking about what material you have to use for construction, making sure that they aren't too heavy, they are the right size, your numbers are visible, the colors are right. And then one of the rules that have changed for bumpers this year is actually that the very last point, or two rules, I guess, but one of the points is, the very last point is that bumper zone rule. In the past, they used to sit the bumper, I think, 2 to 7 inches above the floor. So your bumper would have to sit above 2 inches and below 7 inches, I think, or below 8 inches. This year, they made it so that the bumper zone is actually from the floor to 7 inches above the floor.
Oh, I actually like that change. Yeah.
Yeah, it was a very good change. So that is one of the changes this year. And it is a thing that a lot of problems pop up for bumpers is teams sometimes don't know that rule and don't notice that rule, and they may start building bumpers higher than 7 inches. They may build a bumper they see that's 3 inches from the floor, but a typical bumper is 5 inches tall. So they will extend past that 7 inch above the floor gap. So that is something to look out for when you're designing your robot.
All right, and we'll get back to bumpers in a bit, because this is one where every year we see issues with even experienced teams and their bumpers, but we'll talk about some of the more common issues that do crop up with those. But let's keep pushing.
In terms of the inspection, it's very basic. The inspector will go through, kind of feel your bumpers, make sure everything is made correctly, and then measure your bumpers and make sure that they're in the right location, the right size. Make sure your colors are right, your material, and your numbers are right. That's the basics of inspection.
Very nice.
Yep. And then moving on to the mechanical checks. Most of these are pretty straightforward. Just not having, most of them are just safety rules, really, just making sure you don't have sharp edges, you're not using any crazy materials like lasers and noxious gases. Usually not a problem at all, but something that we have to go through and make sure robots are safe. And yeah, it's just basic checks, making sure the robot is safe for everyone, and nothing will damage the field or potentially damage other robots on the field. And then I think we're going to be going over that cost accounting worksheet later on as well.
So we'll
really,
we'll circle back to that, but we'll do that separately once we get through the checklist. But that will be an important one. That is a form that you do have to fill out, and we'll take a closer look at that form once we're done the checklist.
And then the new rule that they had in this year is the servo cost rule. In the past, they only had a specific servos, I think, limited to a certain current, a specific current that you can use. This year, they opened up to any COTS servos as long as they're less than $75. So that's a new checklist item for non-rookie teams.
Yeah, and we'll just expand on what this COTS acronym stands for. That stands for Commercial Off the Shelf, and so that just means it's a servo that you can just buy at a store, you know, and just use it pretty much right off the shelf. And so the servo rules is something that's come up in a previous webinar. They've been a lot more lenient this year, but yeah, you can pretty much just buy whatever servo you want as long as that one servo, the cost of one servo is not more than $75. So.
And then moving on to electrical, same kind of deal as mechanical. It's just really going through this checklist, making sure you have all the right pieces, that you have the right power distribution in the panel, you have the right radio, you have the right wire sizes, going to the right places. So it's a very much a visual check and also a verbal check. So a lot of times inspectors would be talking to the students, just asking, hey, can you point out all the motors? Can you name all the motors? Can you trace this wire back to your motor? What gauge is it? Some of it is a very verbal check, and it allows the inspector to really engage the students and make sure that they know what's on the robot as well. And it's probably the fastest way to do an inspection is to have the students point out exactly where everything is. But it's a very straightforward check. One thing that has come up before is that main breaker accessibility. When you're designing your robot, you do want to put your main breaker somewhere easy for a third party to access. So if there was ever an issue on the field, our FTAs will if the FTAs need to turn off your robot, they need to be able to easily access your main breakers and turn off your robot.
All right, and an FTA is a field technical advisor, and they're the person off to the side of the field who's basically running the field. They're starting and stopping all the matches, and whenever there's any issues with the field, they'll be fixing them and addressing them, and they would be the person where if there's a robot for some reason that needs to be shut off, either before, during, or after a match, they would be the ones responsible for doing it. And so generally speaking, the rule of thumb is that your main breaker has to be accessible and obvious enough that someone without any knowledge of your robot can quickly and effectively determine, you know, how to turn off that robot and to be able to actually turn it off. So if you've got your main breaker, you know, buried deep within the confines of your robot and you have to remove panels to get with it, that's going to be a no-go. That's not going to be good. And so we've run into some issues like that in the past, but generally speaking, you know, most teams put it in a pretty accessible spot just because you, as your own team, need to be turning your robots on and off pretty often, and generally you want to make that convenient. So generally, if you're doing a pretty good job with it, we don't run into too many issues, but we've seen it crop up in the past.
Yep.
All right. Actually, I'll touch upon one right at the top very quickly here, where modifying motors is an interesting one, where, you know, you're allowed to modify your motors a little bit to machine down the output shafts. You can cut down the motor wires, but you can't be drilling holes into the body of your motor, for instance. And it's kind of a rare one, but for younger teams who kind of don't really know where the boundaries lie for being able to modify a motor, this is just one to be aware of, that really there are some restrictions on being able to modify a motor. You can't take it all apart and redo the windings, for instance, to try and squeeze some extra torque or speed out of it. But yeah, that's a pretty rare one. But a common one is the wire size. The chart is pretty self-explanatory, but this is another one that we do see once in a while. Teams just putting in wire which is just a little bit too small off of a breaker which is a little bit too big.
Yeah.
And Karsin, did you want to skip on to the pneumatic system? Because I think most of the stuff here is pretty straightforward. Oh, actually, maybe the isolated frame might be an interesting one just to talk about quickly, because I know this is one that some teams do run into some issues with, but can you just explain that one for us very quickly?
Yep, we just want to, for this check, we want to make sure that your frame is not in any way connected to the power system in any way. This could be achieved really by even just a stray wire that has a little piece sticking to the frame. We want to make sure that whatever is connected to the battery terminals is not connected to your robot frame.
Right.
And I have seen robots connected to their batteries through their frame, and it's not a pretty sight. I think we've both seen that.
Yeah, and they can result in some pretty spectacular electrical meltdowns, and even So that's one that is checked by taking a digital multimeter and just checking for resistance between the battery connector, both the positive and the ground, against the frame. And you can see right here, we need to see more than 3 kilo ohms of resistance between that battery and the chassis, or between that battery connector and the chassis. And if not, that means you've got a short. Something is on your frame is connecting up to your battery. And this is a really interesting one because a lot of the times it could be a frayed wire. But in some really mysterious cases, this could also be indicative of a bad motor. So there's some motors where if there's a problem with them or there's an internal short in them, it might short one of the wires to the body of the motor. And the body of the motor is attached to your frame more often than not. And so if you get stuck with one of these isolated frame issues, oftentimes that's something to look into.
Yep. And I know it's starting to get a bit popular of these LED strips that are getting pretty inexpensive to put onto your robots. Some of these do cause problems with isolated frames. I've seen some robots start connecting to frames pretty easily through these LED strips. So it is something to be careful of.
All right, moving on to the pneumatic system. Karsin, can you just tell us briefly how you guys do the pneumatic system check?
Yep. Basically for pneumatic systems, in the rules there is a pretty specific list of items that you do need to have on throughout your system, and there are even images that show exactly where they need to go and explanations that go with them. And basically we just go through that list, making sure that you have exactly all the parts, all the pressure relief valves, all the regulators, all the gauges, and we make sure all of that is in there before we even let you put air into it. We also make sure that nothing is modified. You can't be drilling holes or painting compressors or painting your sorry, I lost the word.
Your solenoids or
anything.
Fittings.
Yeah, fittings. You shouldn't be modifying anything. So we just go through, make sure that everything is there, and then once everything is there, during the power on check, we will actually start pressurizing your system, making sure everything is acting the way it is, making sure your pressure regulator is actually limiting it under 60 psi working pressure, making sure your relief valve is actually releasing at 120, and making sure your, what is it called, compressor control is will actually stop your compressor from going past 115.
Okay, so I've seen you guys do this check before, where, in a sense, you'll intentionally try and overcharge the pneumatic system,
Yes.
and you'll need to see the pressure relief valve first of all should open up and release, and then you'll also just let it run normally and just double check that the compressor does actually
turn off.
Yeah. All right. All right. And then last few items here, Karsin, power on check. Can you tell us just a little bit about this section?
Yep. So the power on check is mainly to make sure that everything turns on properly. All your RSL, your robot signal light, will also turn on and works correctly. The power on check also includes make sure that your firmware for your driver station, your rotor reel, all your speed controllers are all in order. They do put up updates ever so often, so make sure you're updating your driver station before you come to the competition. A lot of times we spend a good hour just going around updating everyone's driver station. So if you can, before coming to competition, do that, it'll save yourself a lot of time. So yeah, the basic power on check is really to make sure your pneumatics work, all your lights are working, and to make sure that we can also power off your robot. So when we turn off your robot, everything actually turns off. And then we will also vent your pneumatic system to make sure that all the air will actually vacate the system.
All right, very nice. And then rope inspection. This is a new and very special one for this year. I don't know, Karsin, if you have lots of information on how the inspection of the ropes is going to happen, but if you do, can you enlighten us?
I don't have too much information on how the rope is. There isn't really a standard that we've set up yet for rope inspection because it is a new thing this year. But it's really just going through the rules in IO4 and making sure all of that is followed to the letter. And I believe we're going to be supplied with serial tags for each rope. So as we pass each rope, we will provide it with a serial tag that goes onto it. And that's what the field crew will look for when you attach a rope. That it is a rope that passed inspection and it has a serial tag.
All right, very nice.
And I believe you're not limited to how many ropes you can have. So you can get multiple ropes inspected for your competition.
And I also know that it's not also specific to a team, which means you can bring, a dozen ropes and get them all inspected. And if you loan out those ropes to other teams, they don't have to get them re-inspected. Once a rope is inspected by an inspector, it can be used by any team. So if you are in the mood to share a rope, you are more than welcome to do so, as long as it's passed inspection at some point with some team. It's fair game for anyone to use.
Yes.
Awesome. All right, so let's talk a little bit now about the cost accounting worksheet. This is definitely something that needs to be filled out. And I'll pull up the cost accounting worksheet. And Paul has just reminded everyone in the audience that a copy of all these forms have actually been included as handouts on this webinar. So if you click on your handout panel, you may just want to download a copy of all of them just so you have them all in one spot. But this is the cost accounting worksheet. And it's basically going to hold an itemized list of the components that are going onto your robot, but there are some exceptions to what you include and what you do not need to include onto this worksheet. And so let's talk about the stuff that you don't need to include, because we want to make this as easy as on teams as possible. And so any items that came in the kit of parts, you do not need to include on the cost or on the cost accounting worksheet. And so control system, the motors that came in the kit, speed controllers, connectors, wires, those types of things that came in the kit of parts do not need to be included. And so I've just given an example of something that you would include on the cost accounting worksheet. And so it's been broken down by subsystem here. And this used to say subsystem 1, but a lot of robots are probably going to have some sort of mechanism to hold a gear. And so you're going to change that subsystem 1 to the name of your subsystem, in our case, the gear holder. And a lot of gear holders are going to be made out of aluminum, aluminum extrusion in particular. And so here's our item. We have some extrusion, description, 1-inch by 1-inch L channel made out of aluminum, and maybe you bought it from McMaster Car. You bought one length of 8 feet. And on McMaster Car, the cost is actually $17 US. And so this cost accounting worksheet, Karsin, you'll probably just speak to this very quickly, but the cost limit for your robot based on this cost accounting worksheet is $4,000 US. And although that might not sound like a whole lot of money, because the kit of parts includes so many parts, generally the stuff that's outside of the kit of parts is actually not that expensive. Things like aluminum extrusion are pretty inexpensive. And Karsin, how often do teams even come close to that $4,000 US dollar figure, would you say?
I haven't even seen one yet so far that passes the 3,000 mark. I don't remember one that passed 3,000.
So basically, if you're getting close to that 4,000 mark, you've probably done something either wrong or really odd or weird with your robot that has caused it to be really expensive. So generally speaking, you should not be anywhere close. Even with, an ultra competitive, super high-end robot, once again, because the kit of parts does cover so much of the high value items on your list, that you don't need to include them. And I'll give another example, speed controllers. So if you have, 10 speed controllers, Victor SPs, which happen to have come in the kit of parts. I know it didn't come with 12 of them, but it did come with 2. You don't have to account for any of them, in fact. So you're not even limited by the number that came in your kit of parts. If the item came in your kit of parts, you can account for, an unlimited number of them, essentially, on your robot. So you don't have to worry about those. And also, a small little item here is that any items, any COTS, so again, that's commercial off-the-shelf items that are less than $5 US dollars each, do not need to be included either. So if you're thinking, oh, do I have to cost account for every little fastener or rivet on my robot? Nope. If that component's under $5, it doesn't need to be on your worksheet. And so this is interesting because the purpose of this worksheet isn't necessarily, to hold teams to tasks that they're absolutely under this $4,000 cost limit, because the truth is, it's really hard to get up to that cost limit. Karsin, what would you say the purpose of this cost accounting worksheet is more so, honestly?
This is really, it's like a real world exercise of, this is something you have to do in the real world when you're designing any kind of mechanism. When you're designing, say, a robot for work, you need to go through this process of making a cost accounting worksheet of all the parts you're going to be needing, how much of each part. It's a good exercise to go through, and understanding exactly how much your product is going to cost you. And that's how you really work out, how can I make it cheaper, how can I make it better, is by looking at this sheet.
Right. So,
and I think that is more important overall than really holding teams to that $4,000 and evening the competition out.
Yeah, I agree wholeheartedly with that one. So good information for you guys to know. Sorry, Karsin, did you have something else you want?
For that cost accounting worksheet, one thing to look out for in R11 is that each individual item that's not a kit of parts item that you list on the sheet can't be over 400 USD.
That's right. So one individual item. So if you have like a $500 sensor for some reason on your robot, that's going to be a problem. That single sensor, there is a single component cost limit of $400. So if you have a single item on here which is more than $400, you will run into an issue with that. So one thing definitely to be aware of. Thanks for bringing that up, Karsin. That one doesn't happen too often, but I guess I have seen it in the past. But another form that you'll need to complete just before you finish bagging up your robots, and that is something called the robot lockup form. And so this is just to prove that you have sealed up your robot and that basically you're not going to touch it after it's been sealed up. And so it's a pretty straightforward form: team name, number, home city, and then on stop build day, before midnight, you are going to have an entry at the top here, date, time, signature, and the signature does have to be someone who is an adult. So 18 years or older. Oh, wait a minute. It says here, not a student member of the team. Okay. So you can't be a student. It's got to be an adult. And basically, just any adult. And on this column here, security seal number. So this is really important. When you seal up your bag, in your kit of parts, you would have been given a number of, they look like giant zip ties. They're a little bit more intricate than that, but they all have serial numbers on these tags, on these zip tie seals. And so you've got to make sure that you write down the exact serial number on the tag that you've used to seal your robot, and that it matches this form. Because when you bring your robot in its bag to competition, the robot inspectors will verify that the number on this form is precisely the same number as that unbroken seal that you used to seal that robot. Print your last name, first name, pretty straightforward. Contact cell phone number. Please make sure that's someone who's going to be available to take a call at the competition, because if there are any issues, a robot inspector will pick up their cell phone and dial them immediately. And then just tell us whether you locked up the bag or unlocked the bag, and we'll talk about reasons why you would unlock a bag later on. But for stop build day, this will be L for lock, and your explanation will be just stop build day, because on stop build day, you got to lock up your robots. So it's pretty straightforward for your robot lockup form. When you show up to competition, you'll have another entry right underneath that showing that you've unlocked it, and the explanation will be to compete at your district event. And so we'll talk more about locking and unlocking, because there's some other reasons why you would unlock and relock up your robots as we go on. But pretty straightforward form, but this is a very, very important form. You want to make sure that it's filled out accurately, and you want to make sure that it doesn't get lost. This is your lifeline. Without this bag, or rather without this form, you're not going to be able to take your robot out the bag. And so I would highly recommend the moment that you fill it out, you make some copies of it, distribute it to the most trustworthy people on your team, and make sure that it shows up with your robot at the competition. And I know there's some teams who think, oh, well, the smartest way for me to do this is to lock it up inside the bag. Robot inspectors would actually ask that you do not lock up this form inside the bag, because the inspectors have to read the form with the robot still in the bag, and that becomes really difficult to do. And so please keep the form outside of the bag, and just have someone present it with the robot when you drop it off in your pits. And they'll instruct you. Most of the time you just leave the form on top of the bag in the pits, and if the inspectors have time, they'll even check it over, kind of overnight, in fact, if you have that opportunity. Well, actually, no, with the district model, you won't have that opportunity. So generally, just leave it on top of your bag and call an inspector over, and they'll take care of it for you and do the checks for you. Mm-hmm. All right, so I think that's it for the robot lockup form, and we're running a little bit low on time. Most common inspection problems, we did talk about these in passing, but we'll just reiterate them really, really quickly. Karsin, yep. Run through a few of them for us very quickly. What are going to be this year's most common inspection problems?
So the most common inspection problem really is the bumpers. A lot of teams, because it's not part of the robot, it doesn't have to be bagged with the robot, the bumpers are left to the very end. And really they shouldn't be, because they are part of that volume we talked about earlier. So it really has to be incorporated in the design of the robot. So a really common problem that I foresee is that teams will forget that bumpers are part of the volume and design bumpers outside that volume, and we will have to work out a way to bring that in. So make sure bumpers are part of your design. Make sure they're within the volume that you chose, and that will mitigate a lot of the problems.
Very nice. And actually, while we're talking about bumpers, Karsin, what are your thoughts? Do you bag your bumpers with your robot normally, or do you take your bumpers separately to competition? There's pros and cons to both, but do you have a preference?
I would rather bag them if I had the option. So if they're complete, I would bag them. I know some teams like to keep the bumpers out because they may build a second robot to practice with, so they need a set of bumpers to really fully experience their full robot, and that's very fair. But I would even just suggest making another set of bumpers for their other robot. So in my opinion, I would put the bumpers in the bag if you have them done.
All right.
And then you're guaranteed to have your bumpers at competition.
All right, and yes, because bumpers get forgotten all the time. That's really embarrassing, but it happens every year. I won't go go to the point to say it happens every competition, but it does happen every year where a team forgets bumpers or bumper of one color or the other, and it becomes a really tricky situation. More common inspection problems. Pneumatics are a pretty tricky one. A lot of the times it's like a relief valve that isn't working. It's not releasing at 120, 125 psi. Regulator's not working for some reason. So like we said, we're going to overcharge your system on purpose. We're just going to make sure that, you know, it doesn't breach the 60 psi limit for, you know, your lower pressure side. Your gauges kind of not being on the right sections. We got to see a gauge on the high pressure side and the low pressure side. And sometimes just the order of all those different valves, relief valves, and the regulators and the gauges. Sometimes if they're not in the right order, it can cause issues and not give you proper readouts. So that's one that we've run into quite a bit in the past. We've already talked about the main breaker, so I don't know if we need to talk about that too much. And then another one that we have down here is wire size, not matching the size of the breaker, and also speed controllers. You know, the speed controllers kind of dictate the wires a little bit and what they need to be hooked up to. And I think, Karsin, you mentioned that was rule R35, where they have this nice little chart here. And sometimes robot inspectors, we do find some issues here where, okay, you've got, you know, a certain type of motor like a sim, and you're allowed to hook it up to a motor controller, but someone has hooked it up to a spike relay instead. And that's kind of a no-no. And little things like this in terms of what you are not allowed to hook certain things up to. And what's interesting is that there's even some motors here where you can hook up more than one motor to a single speed controller. And there's some where you're not allowed to hook up more than one to a single speed controller or motor controller. So this chart basically becomes kind of the Bible when in terms of the electrical wiring and what you're allowed to hook them up to. And then in terms of the actual wire gauges, it's actually a lot more straightforward. Back to the inspection guide for wiring. You know, the size of the wires are basically just dictated by what size breaker you ultimately have protecting that wire. And so that's a pretty easy check there. That one has gotten a lot simpler over the past few years. All right, Karsin. So those are the more common ones, and we talked about them kind of twice. And so I think we're good with those. But let's talk about failing inspection, which happens to the best of teams. Even on 610, you know, we get our robot out, we put it through inspection immediately, and very rarely does it pass inspection the very first time that you try and bring it through. And so, okay, I failed inspection, Karsin. What do I do at this point? Do you have any advice for teams?
Yep. So one of the roles for the inspectors isn't just to be there to make sure you're following the rules. They are there to help you. So when they do find something that on your robot that does fail the inspection, they will actively try to help you figure out how to fix that. They will work with your students. They'll talk to your students. It could be as simple as just changing out a wire, or just removing or changing the breaker. It could be simple as that, or it can be as complicated as shortening a whole side of your robot. They will be there to support you. And another thing that we can help you guys with is to connect you with other teams. And that is a big thing as well.
Yeah, and so two super important points. It's sort of like I've seen teams get frustrated when they fail inspection, and you know, the best teams fail inspection. It's almost part of the process. But the two amazing things about FRC right off the bat, that inspector is actually there to help you. And I see so many teams, you know, because they're an inspector and they've never done FRC before and they think it's very adversarial. The inspector's like stopping you from competing. That is 100% not the case. The inspector's actually there to do what they can to get you onto the field so that you can compete. And they will, you know, we have amazing inspectors in Ontario. They bend over. I've seen this personally. They will bend over backwards to help you in whatever way they can to get you competing and out on the field. And so work together with them. Don't just automatically say, oh my gosh, this person is just trying to prevent me from getting onto the field. Yes, they've pointed something out that didn't follow, you know, the letter of the rule, but they're there to help you get out onto the field. And if they can't help you personally, more often than not, they will connect you with someone who is willing and able to help you. And a lot of the times it does come from someone from another team. And I don't want to say a rival team because, again, you mentioned it, Karsin. Another great thing about FRC is that the teams genuinely want to help you. And so don't be intimidated by that. If a robot inspector is sort of like, hey, here is such and such person from Team XYZ, and they've got some tools, they've got some parts, and they would love to try and help you out with your issue, please accept that help. Don't feel bad about it by any means. Make sure you have some students around to help them, help you with a robot, and they can learn sort of what the issue was and how to correct it. And it ends up being a super positive experience for everyone involved. And so just don't get your hopes down if you do fail inspection. It happens to everyone. Work positively with that inspector because they are there to help you. And even if another team gets involved with that, please accept that help. It's going to end up being a really good thing. I guarantee it. Absolutely guarantee it. So thanks so much, Karsin, for highlighting those points because they are super important. It's one of the things that makes the FIRST Robotics competition so special and basically different than any other sport that I've ever competed in. All right. Now, most of you are not done your robots, especially since we've got 2 more days before stop build day. Are we at 2 days or is it? Yeah, okay.
1 day.
1 day.
1.5 days.
1.5 days. Most teams are not done their robots. I was going to say like 90% of the teams won't be done their robots at stop build day, but really that number is more like 100% of teams are not done on stop build day. And so the quote is, we're still not done our robot. Help. It's pretty much everyone. There are ways for you to continue to work on your robot that we need, especially the younger teams, to know about. One of them is called the Withholding Allowance. And so this allows you to claw back 30 pounds of what are called fabricated parts. And you are allowed to work on those 30 pounds of parts unencumbered for as long as you want up until, your competition. And what happens is, you basically show up to the competition and you say, hey, here's my 30 pounds of parts that I've been working on that's kind of separate from my robot, which is all bagged up. The robot inspector will look at it, and if they feel it's close to 30 pounds, they may even weigh it. But you are basically allowed, 30 pounds of parts to be able to continue to work on between now and, your competition. This is a little different than commercial off-the-shelf items. So you'll see this acronym again, COTS. Commercial off-the-shelf items, so things like motors, speed controllers, or just something that you buy from the store but you don't modify it, it's like untouched, you are allowed unlimited amounts of that. Okay, so those items don't count towards 30 pounds of fabricated parts. This 30 pounds is only stuff that you've modified, that you've cut, that you've assembled. And so an example I could give for how this really works is, say your robot has, I don't know, it has a shooting mechanism on it. And the shooting mechanism it's about 20 pounds. And so you remove it from your robot and then you bag the rest of your robot. But now your shooter, which is only 20 pounds, you're using that as your withholding allowance. You can continue to work on your shooter. You can add more parts to it up until it reaches 30 pounds. And then show up to your event with your new and improved shooter that you've been working on all this time. The robot inspector will look at it. If it's under 30 pounds, they'll say, yep, no problem. And then you can install it after your robot's unbagged at competition. And then that shooter, maybe you need to bring, a whole bunch of like extra motors or extra raw materials. Any of those raw materials, as long as you haven't cut them, you haven't modified them, they're pretty much the same state from when you bought it off the shelf. You can have an unlimited amount of that stuff and bring that to competition. And so, yeah, that's the withholding allowance in a nutshell. Karsin, do you have anything to add to the withholding allowance?
I just want to point out, to make sure that it's not just parts that you're modifying to add onto your robot. It can also include, so for that shooter example, maybe your shooter was perfect right at the beginning, you bagged it with it, but you want to make a spare shooter. That spare shooter is still counted within part of the withholding, so I didn't want that explanation to disregard that spare parts that you make for competition. That would be also included into your 30-pound withholding.
Excellent point. Spare parts, because if there's spare parts to your robot, so you've assembled something into a spare shooter, 100% that would count towards your withholding allowance. And actually, going back to that bumper question when I asked you, do you prefer to bag your bumpers or you don't bag your bumpers? If you don't bag your bumpers, I'm pretty sure they now count towards your withholding allowance, and so they'll use up
I
some of this
believe they
30 points.
removed it out of it. Yeah.
Oh, have they? Okay, because I think at one point they were included there. Maybe I won't speak definitively to that one. We'll leave that one just a little bit in the open. I always like to give answers, but if we're not sure on that one, maybe we'll just not necessarily go there tonight and leave that for another night, unless you're 100% sure.
I'll know in like 3 minutes.
Okay, I'll keep moving on, and if you get an answer to that one, Karsin, maybe there's some people who'd like to know that because they're thinking about either bagging their bumpers or not. So, but we'll move on to now the robot access period. And now that Ontario's moved to the district model, this is new for us, and so you are actually allowed to unbag your robot just before the competition to be able to work on it or practice with it. Actually, you can do whatever you want with this robot, but the robot access period starts it is the 7 days leading up to your district events. Okay, and it's got to be a district event. It's not a regional event. It's only for the district events because the district events are technically only 2 days of competition, and that's why they allow you this extra time as opposed to a 3-day competition, which would be a regional event or the district championships. And so the robot access period only for district events does not happen for the district championships, and it does not happen for regional events if you're competing outside of Ontario. But leading up to a district event in the 7 days before, you are allowed to take your robot out of the bag for up to 6 hours total to be able to work on your robot or practice with it or do whatever you please. And you don't have to use all 6 hours in one shot. You can break it up into a few different segments. But every time you unbag your robot, you've got to basically use up a minimum of 2 hours of your 6 hours of time. And so this gives you a fair amount of flexibility in that 1 week leading up to your competition, that you still get an opportunity to work and practice with your robot to take it out of the bag for whatever reasons you wish. Karsin, were you able to get an answer regarding bumpers and whether they take up the withholding allowance? No? Okay.
Oh, actually, I did. So for in R21, right at the bottom, so R21 explains how withholding works, explaining the 30-pound limit, what stuff can be used. You can share your 30-pound limit with other teams at the competition. And at the very bottom of that rule, there are items exempt from this limit. This includes the operator console, robot battery assemblies, and bumpers.
So bumpers are exempt from the withholding allowance. So there is no real downside then to bringing your bumpers separately, not bagging your bumpers, I should say, so they don't count towards your withholding allowance. Good to know. So a little tip for all of you guys. Thanks for looking that up, Karsin. Much appreciated. All right, and that covers the robot access period as well. Karsin, did you have anything to add to the robot access period?
Did we touch on that withholding allowance is used within that 6 hours?
No, we didn't touch upon that. And so going back to your withholding allowance, say you've got your 30 pounds of fabricated parts. When it comes time to open up your bag for the robot access period, you kind of need to, for installing parts onto your robot, you have to respect the withholding allowance. And so again, you can't really prefabricate more than 30 pounds of parts and then install them on your robot access period. Basically, if you're working on parts before your robot access period, you're limited again to 30 pounds of fabricated parts in preparation for using your robot access period. So your robot access period works in conjunction with the withholding allowance. That 30-pound limit of fabricated parts also exists for the robot access period as well. So great point, Karsin. I'm glad you brought that one up because I would have forgotten about that. And so that actually leads us to the end. Sorry, go ahead, Karsin.
Yeah, if teams want to, in R21, there's like a full explanation on how that works with 2-day events, and when you start going into your 6 hours, how withholding will actually work for them. It'll explain exactly how the math goes, and you can keep track of it yourself.
All right. So, yep, pretty detailed explanation of the robot access time and the withholding allowance. So, very nice, Karsin. R21 for anyone who's looking to take advantage of those. And so, Paul, we have now gotten to a few minutes remaining for questions. Paul, are there any from the audience?
There was one that concerned, does this 7-day period, does that apply to each of our district events? And I think we know that it does.
Yep, the answer is 100%. This is per event. And so if you are competing at 2 district events, then you are allowed 2 robot access periods, 1 for each of those events. So great question.
What about the district championship?
The district championship is a 3-day event, and so unfortunately there is no robot access period before the district championships, unfortunately. However, the district championships will have 1 full dedicated day for practice before the competition starts, where you can work on the robot in the pits and practice out on the real field. And so that's the trade-off. So the rule kind of is for any of those 3-day events where they have a dedicated practice day, there is no robot access period. But then for our 2-day events where we don't have a dedicated practice day, to make up for that, we're giving you the opportunity to take advantage of the robot access period.
So one other thing I wanted to point out was Karsin earlier said about lasers. Should you put a laser on your robot, it has to be a specific kind of laser.
Class 1.
Class 1, and you need documentation to show the inspector, correct?
Yep.
Yep. And it is a little difficult to find a visible Class 1 laser. They do exist, but you got to be careful with that one because the overwhelming majority of visible red dot lasers that you find are generally Class 3, so you do have to be careful about that one, but they do exist. You do have to hunt around them for a little bit, but you got to ensure that it's a Class 1 laser. Can you confirm that, Karsin?
Yeah. So bring documentation if you're using a Class 1 laser, and that's what the inspector will look for. Right? As soon as they see a laser, they'll ask, is it Class 1? Show me your documentation for it. And yeah, that's all they need to confirm.
All right.
That's it for our questions.
Great. Well, thanks very much, everyone. We really appreciate it. And just to remind you guys that next week's webinar, we'll get a chance to take a look at some robot release videos. So for those of you who are new to FRC, what generally happens is there are a lot of teams who release videos of what their robots look like, what they can do. And at that point, there's a good number of Canadian teams who are pretty reliable when it comes to releasing these videos. We'll get a chance to take a look at our fellow Canadians out there, and hopefully we'll get a chance to see some videos from the powerhouse teams, the ones that a lot of teams pay a lot of attention to, who generally end up being some of the higher performers. And actually last weekend there were a series of what are called Week 0 competitions. And we'll have a chance to maybe take a look at how some of those matches played and whether it matches up with what we predicted in terms of how the games would be played, what the scores were, and to maybe try and use some of those observations to predict what's going to happen at our own Week 1 competition, which will be at Durham College not too long from now. And so, seeing no other questions, thanks very much for spending this family weekend evening with us. And good luck with your final day and a half of build season, and best wishes and good luck to all teams. Have yourselves a great night.
Night.